morning. My name is Alex and I'm an educator here at the Emerald Coast Science Center. Today I'm going to be talking to you about density, and we're going to have a really fun DIY project at the end for you guys to participate in. So do you guys know what density is? So density is how compact a substance is, or how much matter takes up the space of the substance. So there is an equation to calculate density. It is mass divided by volume. So we have an example here. I drew a little picture, a little square. You can see how many particles are compact into that little square versus this square over here where things are a little bit more spread out. So you can see the density of this square is greater than the density of this square. So density is temperature dependent. As a substance heats up, it typically expands, so you have a lot more space for those particles to bounce around. So their density changes as the temperature changes. And then as the things like water freeze, typically a lot of substances will become more compact, so those atoms are getting into a tighter space, so density does increase. The one thing where this doesn't count is water. So when you think about water, water freezes, it expands. So it's allowing more particles to bounce around, and that's why you have things like ice that float. So you can kind of see here, I've got my water down below. My water is denser than my ice. And as a fun fact, if you, I believe it's the Dead Sea, if you go to swim in the Dead Sea, you will never sink, just because the water, all of that salt and everything, is denser than your body. So you're just going to float at the top there. So we're also going to be talking about polarity today, just a little bit, that way we can understand the difference between our liquids that we're going to be using for our project. So polarity does refer to the way in which atoms bond with one another. If a substance is polar, it has a lopsided electrical charge that attracts with other atoms. So for this example, it would be water. So you can see our water molecule here. We've got H2O, we've got our two hydrogen atoms right up here, and we've got our oxygen atom down below. So our hydrogen atoms are positively charged, and our oxygen atom is negatively charged. Only because we only have one oxygen, it is lopsided charge. We've got two positives, one negative, so that allows water to mix with other substances better. We also have non-polar substances, so that would be where the electrical charge is evenly distributed across a molecule. So what we're using today would be things like baby oil, or what I have is canola oil. So oils, fats, greases, things like that are typically non-polar, so they're not going to be able to combine. One of the things, like I said, density is mass divided by volume. If you're able to see here, I've got the same amount of water and the same amount of oil. They're in the same containers, everything's weighed the same. But as you can see right here, our water requires 550 grams in order to be even on the scale, whereas our oil here requires 472.5 in order to be even. So the volume has remained the same, however, the mass is higher, so density of water is higher. So I'm going to be using these today in order to mix them up. What you're going to want to do is you're going to want to take your water and you're going to want to mix it with some food coloring. Just that way you get some fun color. Kind of looks, what we're doing is a DIY lava lamp. So you're going to want some colored water to float up into that oil. So we're just going to squirt a little bit in there. I'm going to remove this scale so you guys can see a little bit better. So I'm just going to stir this a little bit. Hopefully you guys have some really cool colors at home. Just make sure that food coloring is fully dissolved. I'm using gel food coloring, so it dissolves a little bit. Takes a little bit longer to dissolve in there. So I'm just going to pour this into our graduated cylinder here so that way you can see our reaction. We'll take our oil. We're just going to pour this on top. And as you can see, it's already separating. So you see the green color versus the yellow there. So that yellow is my canola oil, that green is that water mixed with the food coloring. So as much as I can mix that up, let me see, I can show you where I'm stirring it. I'm trying to combine the ingredients right now. And you might notice the oil and the water don't really separate at all, or they don't mix at all. All they want to do is just separate. I stop stirring. You can see that the particles down there are swirling around, and they're going to slowly separate as time goes on. So what we're going to do now is we're going to grab those Alka-Seltzer tablets, those little fizzy tablets that we just drop into the water, and it's going to cause the color to rise up. So I'm just going to grab a couple of my pieces, just put them in, let them sink down. You can see it's starting to bubble up, and all my color is going to the other side, so I kind of got to show you here. But as you can see, the water goes up just like you would see in a lava lamp. And so I have a lot of water and oil here, so I'm just going to add another Alka-Seltzer tablet to help you see a little bit better. Just going to make its way down. You can see it pushing up through there. You see the green going all the way up. So do you guys know what's happening in this reaction? Why the water is being brought up through the oil? So what's happening is the Alka-Seltzer tablet is dissolving and it's creating carbon dioxide. Carbon dioxide is a gas, so as it dissolves, the water attaches to that gas and it flows up to the top. Now, as the gas approaches the top, the bubble pops. And so what's left is just that water molecule, which again is denser than our oil. And so the water molecule just drops right on back down. So you can kind of see our lava lamp is heating up slowly. So you can see the molecule here just kind of increasing slowly. Hopefully by the end of this it'll bubble up a little bit more. But lava lamps, while they don't use the Alka-Seltzer tablet in order to do this, they actually use two liquids, and that, again, a polar and a non-polar liquid. They're usually a lot closer in density than oil and water would be. But we don't use an Alka-Seltzer tablet because we have a heating element in here. So the light bulb in here is heating up the denser liquid, causing it to go up and push through. And as that denser liquid flows to the top and becomes less dense, it's cooling down. Now because it's cooling down, it no longer has the ability to become less dense, and so it becomes more dense than the substance around it. So it floats back down, and you would have it goes up and down and just revolves. And so just to kind of show you a little bit of what I'm talking about, this is one of our hand boilers, and so you have to be really gentle with these, but you can see the red liquid in here. As I hold it in my palm, you'll see that it moves up. And so that's just exactly what that lava lamp is doing. It's causing that liquid at the bottom to heat up in order to move away. And so as I take my hand away from it and put it down in its box, you'll see that it starts to go back down. I can't really touch it, otherwise it'll stay heated, but I'll just leave it there and you guys can see it. Alrighty. And so that is my lesson today on density. Hopefully, if you have any questions, go ahead and put them in our comment section. Otherwise, if you just want your voice to be heard, make any cool comments about what your lava lamp's doing, take pictures and send them to us, go right ahead. That'd be really cool. But other than that, we are still closed, unfortunately, due to the COVID-19 pandemic. But we do ask that you go ahead and give us some feedback, see what you'd like to see. We'll be doing this all month long. We also have a donations link that you can do, or you can sign up for a family membership. It lasts all year long and it won't start until we're back open. But that's really a good way to support us while we're still closed. But that's my project today. Hopefully you guys had fun. Thank you.